this equation gets a little ugly. It's another rational equation, which is complicated enough. And then it's full of trig functions. So the way to deal with this is, first, remember your training, pretend that it's just a rational equation, and try not to think about all the trig stuff we're going to have to do. I'm going to cross multiply to get rid of the fractions. Okay, in other words, I'm going to multiply both sides of this thing by both denominators. I'm going to multiply both sides of the equation by cosine, or by negative cosine actually, and that's going to cancel out this denominator. And I'm also going to multiply both sides of the equation by sine minus 2 cosine, and that's going to cross out the other denominator. So by the end of this, once all the dust is settled, I should have no fractions left anymore. So let's go through this, and we'll work on one side at a time. I'm going to start with the left side first, okay, this side right here. So that's going to be negative 3 sine omega times negative cosine omega, and the denominators cancel out. Great. So now we're moving on to the right side. The right side is going to be equal to, let me get my denominators back here. It's going to be equal to 2 sine omega minus cosine omega. The negative cosines cancel out from the denominators. So it's going to be times sine omega minus 2 cosine omega. Okay? So that doesn't look so bad. Let's continue working with this and see where we go. So on the left, this is negative 3 times negative 1. That's just going to be 3 sine omega cosine omega. Okay. On the right, there's a little bit more going on here. And I encourage you to use foiling, okay, to come up with this. First, I'm going to do negative 2 sine times sine. That's going to be, I'm sorry, I don't know where I came up with that negative. It's positive. 2 sine squared omega. Okay. And then we'll try the outside terms right here. So that's going to be minus 4 sine omega cosine omega. Okay, and then we're going to try the inside terms, negative cosine times positive sine. So that's going to be another negative sine cosine. And the last one is the outside, or the last terms. So negative cosine times negative 2 cosine is plus 2 cosine squared omega. Now, the reason I'm being so careful with this foiling is because this is actually my second video. I messed up the first one. I didn't even find the mistake until the end because everything just worked out kind of nicely by coincidence until I tried plugging in the values back into the original equation. And then I realized it was just a big hot mess. So we're going to be real careful with this factoring here, or this foiling. I have 2 sine squared minus 5 sine cosine, and let's just be official about this and use angles. 5 sine omega cosine omega plus 2 cosine squared omega. Okay, so I've got some work to do, and obviously combining like terms is where I want to start. So I've got a 5 sine cosine over here, a negative 5, and a positive 3 of the same thing over there. I can combine those together by adding 5 sine omega cosine omega to each side. Okay, just like we would add any other variable to each side. It's just that this variable tends to be disgusting. So what do we get? We get 8 sine omega cosine omega. Okay, great. And on the left, on the right, sorry, we have 2 sine squared omega plus 2 cosine squared omega. Well, something about this should be jumping out to you. One thing maybe is that we could divide all sides of this whole equation by 2. Okay, sort of simplify things a little bit. Always be on the lookout for GCFs like that. And when you divide each side of the equation by 2, you get this. Sine squared cosine squared on the right, or rather the sum of those things. And on the left, we have 4 sine omega cosine omega. Okay, pause the video. Go look for an identity because we're not factoring this thing very easily. You're not going to be able to find a GCF here. You're not going to be able to find a trinomial factoring that'll work out nicely for you. So we need to use identities of some kind. You have a bunch of choices. We're actually going to use several. So Pause the video, see if you can figure this out on your own. But I'm going to point out to the Pythagorean identity as the first one that jumps out at me. And we've got a Santa Claus right here. Sine squared plus cosine squared, that's just equal to 1. So I can rewrite this whole thing as 4 sine omega cosine omega equals 1. Well, that's great progress. And now what? Well, 4 sine omega cosine omega. You can't use a quotient identity because that involves fractions like sine divided by cosine, and that's not what we have here. We have sine times cosine. We don't have any squareds, right? No exponents, I mean. So I don't think the Pythagorean identity is going to work again. Now what we're looking for is a double angle identity, which may seem weird because there's no double angles, right? Those are single angles, and yet a double angle identity is our way out of this mess. If you look over here, we've got sine of 2x equals 2 sine cosine. And what do we have here? We have 4 sine cosine. So that is really just 2 times 2 sine cosine, which means 2 times the sine of 2 omega, which means the sine of 2 omega equals 1/2. And now we go to our unit circle and say, where is the sine value equal to 1/2? Remember, that's positive 1/2 as a y-coordinate. Those are these two angles right here. So that means 2 omega equals, what do we have? That looks like shallow angles, pi over 6 and 5 pi over 6. And don't stop there because we've got a double angle. Okay, remember when you have something like 2 omega, that means it has to go around the circle twice. 1, 2, twice around. So that means not only do we have these things, we have, let's see what else, 13 pi over 6 and 17 pi over 6 as coterminal angles, which means divide everything by 2 and you've got your answer. Pi over 12, 5 pi over 12, 13 pi over 12, and 17 pi over 12. So we should talk about, just review the techniques that we used to get to this answer. First thing we did was handle it like a normal fraction, try to get rid of all the denominators. Second thing we did right here, this was a Pythagorean identity. And that simplified the sine squared and the cosine squared part of it. And then the last part we did, the last special thing was right here when we did a double angle identity. Okay, and that got it to the part where we could solve this just using our coterminal angle techniques.